Okay, so our problem is for 158. Again, let's begin by reading the question. Determine the equivalent resultant force acting on the bottom of the wing due to air pressure and specify where it acts measured from point A. So we have an airfoil and there is a distributed load because of the pressure. The function, the magnitude of the distributed load is given as 786 x square kilonewtons per meter. So the coordinate system is given. Point A is the origin of the wing, and so the chord length is 3 meters, as you see, and x-axis is along the wing. Okay, so we are asked for the location of the resultant force and point where it acts. Therefore, we need to calculate the magnitude of the resultant force by integrating the distributed load along the wing. And then second thing is we will calculate the moment generated by this distributed load. And therefore, by dividing these two, we will obtain the location of the resultant force. Now, Fr is perpendicular to the wing, so it begins from A and x is along this direction. So we will integrate Wx from 0 to 3. Basically, the distributed load is acting from 0 to 3, and it is 86 x square dx. Then it makes 86 divided by 3 x cubed from 0 to 3. Okay, so this will give us the magnitude of the resultant force, and the magnitude of the resultant force can be found as 774 kilonewtons. Now let's find the x bar, where the x bar is the distance of resultant force from the origin. Therefore, we have to calculate the moment generated by the distributed load. In fact, at any point, let's say x, the magnitude is Wx. So it is x multiplied by Wx, or in other words, for our problem, x multiplied by 86x square. And this is the magnitude of the resultant force. This integral will give us the magnitude of the resultant force. If I do this integration, it will be x cubed, and as a result, it is x to the power 4 divided by 4 multiplied by 86. So if I simplify it, it is 43 divided by 2. I already calculated this integral, and the result is 774, as you remember. If I put the values, when it is 0, this is 0. If I substitute here 3, the result will be 1741.5, and the location can be calculated easily from here as 2.25 meters.